two different level lines, 500 meters, which is visible here, and 1,000 meters, yeah, in the Riesengebirge area and in the Isera Mountains. The boundary between both countries goes somewhere here, yeah? It is marked with gray color, Polish side and Czech side of the mountains. This part of the mountains belongs to the catchment of Odra River, and in the southwest there is the catchment of Labe River, or Elbe River in German, if I remember well. Yes. Okay. Following indices are discussed in this presentation. So first, annual number of days with snow cover. The second one is the longest continuous time period with snow cover, and annual average from these 5 winters is presented. Then, annual number of days with snow cover deeper than 20 centimeters. It is important, for example, for ski industry. And also maximum snow cover depth, seasonal maximum snow cover depth. Okay. In this graph, you can see all stations presented in terms of annual number of days with, annual number of days with snow cover, starting from 50 to 200, versus altitude, from around 400 meters to the highest point, Śniekope, Śnieżka, 1,600 meters above sea level. So they are quite well, these numbers of days with snow cover, quite well explained by altitude, but not perfectly. This is the same graph you could see a second before, but some of points marked in the graph are also marked with color, representing 2 different regions. So, dark blue markers represent Odra Basin with significant screening from the existing land relief from the southwest. Red triangles represent points in Elba River catchment with no screening from southwest or west. They are simply exposed towards these directions. And green markers are for, green markers are for some sites formally in the Odra Basin catchment, but without significant screening from south or southwest. In general, red points are they represent the Czechish stations, and dark blue markers represent Polish stations, with some exceptions. So, in this picture, you can see that stations representing the Odra catchment have significantly shorter period with snow cover, between 75 and 110 in this altitude span range. Only one station represents the areas at higher positions, a little bit above tree line, but even there, the duration of snow cover is shorter than on the Czechish side. Śrenica, Reiftrager, and Lapska Boda, station in the western part of Riesengebirge. Stations representing Elbe River have significantly longer duration of snow cover. We can see the same picture, the same character of distribution also in terms of the longest continuous time period with snow cover. And the contrast is even larger. For example, at the level between 500 and 700 meters, where ski resorts are situated on both sides of the mountains. On the Polish side, this longest period with snow cover was something between 50 and 65 days per winter period. In the same time, on the opposite side of the mountains, exposed to the southwest and south, in Czechish ski resorts, the duration of continuous snow cover was more than twice as long as on Polish side. Similar situation in case of annual number of days with snow cover deeper than 20 centimeters. If we come back to this slide, such distribution of markers means that on Polish side, even during winter time, there is quite often such situation that some thawing periods between colder periods lead to complete disappearance of snow cover. But on the Czechish side, there is only reduction of snow depth, but some snow still persists such melting period within a winter season. Maximum seasonal snow cover depth shows also similar pattern. So let's look at stations in ski resorts. In Poland, the maximum snow cover is between 30 and 55 centimeters, but in the same altitude range, it is much, much more centimeters of snow depth in case of Czechish stations, between 80 and 110. What are possible reasons for such regional differences? It could be connected with wintertime precipitation, maybe with wintertime solar exposure, but obviously we can exclude this point because these are Czechish slopes which are solar exposed, not Polish. Or wintertime air temperature, maybe some aspects of land use. So let's have a look at wintertime precipitation. This analysis is based on the long-term average, 40 years long time period of precipitation data from both sides of the mountains. And you are familiar with colors. They represent the same regions as on previous graphs. And we can see that lower precipitation during winter time are observed in Odra catchment rather than in Elba catchment. So, at least partly, the situation we could see on previous slides, can be explained by precipitation. I would like to draw your attention to some extreme differences, like here, at the level of almost 900 meters, on the northeastern slope of Riesengebirge, wintertime precipitation is around 210 millimeters. Total of these 3 months, December, January, and February. And similar altitude in the Czechish part of the Izera Mountains, with precipitation around 450 millimeters, more than twice as big. Yeah? Winter temperature. We compared different data series from both sides of the mountains, and on average, the northern slopes between 500 and 1,000 meters above sea level were at least 1 degree warmer than the southern slopes. So this is not solar exposure which rules the situation here. We attribute such distribution of temperature to quite frequent situation with southwestern circulation, which cause fan effects to be present on the lee side of the mountains. Lee side in this case means northeastern slopes, Polish slopes. And in such situation, frequently we have still present cold air in the valleys on the Czechish side with stable thermal stratification, but on the lee side, adiabatic temperature increase if we look downslope from the ridges towards the northeast. So, conclusion, wintertime temperature differences are an important factor controlling snow thawing. And these processes are responsible, for example, for disappearance of snow cover during winter season on the northeastern slopes. Having data from 30 stations, we performed spatial modeling of snow cover depth in this area, and after performing a multi-regression analysis of snow cover versus different factors like altitude, aspect, screening effects, shape of landform, convex or concave, the result was like you can see here. So this is the result of modeling of snow, of annual number of days with snow, ANDSC, and they vary between around 70 to 200, depending on altitude and particular location. We can see that at similar altitude, like here along the level line 500, on the Polish side, this line goes through blue area. And blue area means around 70, 80, or 90 days with snow cover. The same level line on the Czechish side shows green color, which shows annual duration of snow cover like 120 days. It is better visible if we mask some altitude belts, and here are exposed only these belts, 400 to 500, Polish side and Czechish side. Really very different values. 650 to 800 meters on Czechish side in Elba River catchment, and 1,000 to 1,200 meters above sea level, this area. Also similar contrasts. Except of this influence of prevailing circulation, which causes frequent fan effects on the northeastern side of the mountains, causing in further step significant reduction of snow cover, also some other factors are important. This graph represents two sites in a distance of 30 meters from Szrenica mountain top in the western Riesengebirge, 1,300 meters above sea level, a little bit above tree line. And the black line represents the open space inside the meteorological garden, and red line represents mountain pine dwarf bushes, Krummholz, yeah, in German. Yeah, in the Pinusmugum, yeah, in the surrounding area. So we can see significant differences with larger snow depth within Krummholz, especially pronounced at the beginning of winter, when these values are almost twice as high as measured in meteorological garden. These differences are smaller in the maximum development of snow cover. This winter season 2005 was one of the most snowy seasons in the history of measurements in Riesengebirge. But snow cover was so deep that Krummholz was completely covered by snow, yeah? And that's why these differences here were smaller. This graph shows differences between two environments, open space in the west and forested area in the east with prevailing wind from the west. Yeah? And look, these lines represent different phases of snow cover development. The increase in the early phase of winter, stabilization in the middle of winter, and degradation in the late phase of winter and spring thawing. But this graph summarizes these effects. So green bars represent open area just before the line of first trees, and red bars represent forested area in a distance of 20 or 30 meters behind the first line of trees. So we can see here the effect of snow accumulation due to increased friction in forested area, wind-blown snow from the open area is deposited in the forest, giving as the result such differences in snow distribution. So, our conclusions: snow cover in the western Sudetes is a sensitive index of local climate, and there is strong variability on topoclimatic scale imposed by land relief, particularly by the influence for local atmospheric circulation and deformation of atmospheric circulation by the main range of Sudety in the Riesengebirge and in the Isara Mountains, with larger precipitation on the windward side, smaller precipitation on the lee side of the mountains, and lower temperature on the windward side and higher temperature on the leeward side of the mountains. Except of that, there is strong variability on microclimatic scale imposed by the existing land use. My question is if I have 5 minutes more. What's the time?
The time you have not 5 minutes, 3 minutes.
3 minutes, okay. I promised Jörg yesterday to show some slides from our last experiment we performed in the Karkonosze Mountains on snow cover. And the next presentation, it is Annaberger 2. This is Annaberger 1 and Annaberger 2, yeah. Yeah. No. Annaberger 2, yeah, okay. Only 2 minutes left. I'll start before the first slide. Probably a majority of you remember the winter season 2011 to 2012. It was specific. It started with absolutely dry November with no precipitation, and after that there was 3 following months, December, January and February, with more or less 200% of precipitation amounts if compared with long-term norm. And just during this winter, we made some experiment on the deposition of pollutants in snow cover in Riesengebirge. We wanted to recognize size and real rate of pollutant deposition via snowpack, via snow cover. The location of our experiment, western part of Riesengebirge, the altitude 1,215 meters, just a little bit below tree line. The site where wind-blown snow from the ridge is additionally deposited to the snowfall. Yeah, so you can see precipitation. Long-term norm is gray and, no, sorry, long-term norm is black and gray represents the season, yeah? So November, no precipitation, and very high amount of precipitation during December, January, and February. And maybe you also remember that in the end of January, quite cold spell of weather happened with the advection of very cold masses from the northeast. You can see this event here, yeah? With temperature drop to around -20 in the western Sudetes. Just at the turn of February and March, there was significant warming with temperatures even during night staying above 0. And also quite efficient rainfall happened, something like 30 millimeters. So positive temperature and quite strong rainfall on the snow cover, which was here between 250 and 300 centimeters deep. And we could see on the top of snow cover such lines. And we were interested what is the reason for such lines in snow cover. So this is a snow pit dig in the site. My colleague Marek is almost 2 meters tall. So the snow depth here was more than 300 meters, yeah? And equivalent of water equivalent of snow, huge equivalent of snow in this site. Yeah? And at the bottom of the snow pit, after 2 days of melting on the surface of snow and rainfall, there was simply water. But the majority of snow pit profile still stayed in negative temperatures after the long period of frost. And we wondered how it is possible to have water on the ground below snow cover. We noticed it for the first time during following snow pits during the season. And when we looked at the process more thoroughly, it looked like this. So, on the slope in this site, there was thawing of snow from the surface and additional portion of water from rainfall, but it was stopped on first icy layer somewhere in the snow cover, and then it was transported downslope. And this flow of water self-organized into drainage system you could see in the previous slide. But this transport was not continuous for very long distance because there are natural discontinuities inside snow cover caused by single trees. Around single tree, structure of snow is different, temperature of snow is different because of additional portion of water dripping from the crowns and the influence of the tree itself. So if such movement of water meets a position of a tree, it is channeled down to the bottom, and then this water was transported below snow cover downward. Some pictures of these drainage lines. Yeah? And what was the effect for total ionic content in snow cover? If we summarize major ions, they are represented by different colors here. During the first days of March, there was only 14% of water melted, and it disappeared from the site, but approximately 123 millimoles of different components was released, which was 45% of total ionic content before the start of this melting. So I would like to show the paper where you can see more thoroughly the results of this experiment. And this is our observatory, university observatory at the top of Mount Strzenica, and here is the door to the observatory.
Very well hidden.
Yeah, thank you.
Vielen Dank, Herr Sobik, für den Blick in die komplexe Schnee.
Many thanks, Mr. Sobik, for this insight into the Sudetes Mountains. Are there any questions?
Ja, Jörg.
I'm sorry, I will be speaking in German so that the translators work. Ich möchte auf das letzte Thema von dir
I'd like
kommen.
to ask you about the final topic.
Ich möchte auf das letzte Thema
The final
Chemie
topic
und,
chemistry and the transport of chemical components, because I'm particularly interested in this topic. Thank you very much for having taken the time to show this. I saw chloride as a highly mobile tracer is less mobilized than sulfates or nitrates. Is there any explanation for this?
To be honest, in the team of authors here, I represent the climatological path, yeah? But anyway, this is well known, and different ions behave in different way. And they are present in crystals of snow cover in different with different resistance for melting, yeah? And that's why nitrates are more mobilized than chlorides, for example. It is okay, sulfates were reduced significantly, and nitrates, but chlorides in much smaller rate. But sorry, I am not able to explain the microphysical and chemical reasons for that.